And I'm right back. Woo, that was less than a minute in real time. All right, we are doing the next part of today's lesson, and we're going to fill out some stuff. We're going to go really fast through this. This won't be a slow situation. We're going to figure out reasons for a lot of givens and a lot of if-thens and givens and stuff like that. 1 plus 2 equals 180, and 1 is equal to 3. Those were given to us. Figure out what happened. Angle 1 went away, and it became angle 3. So how does 1 become 3? That is a substitution. It was removed and replaced. AB goes to TH, TH goes to D dub, therefore AB goes to D dub. Oh gosh, you're going to be so mad. Please don't look. Please don't look if you're another math teacher, but we're going to call that substitution. Oh, that feels bad. That's okay. Technically, it's transitive, but we are not giving a good enough lesson on transitive. If you watch the last video, we're not doing a big lesson on transitive, and it's too hard to get right without a long explanation. We're not doing it. We don't have time anymore. We're going to just call it substitution, and we're going to live with it. There should be a little m here. Where little m means measurement, so we're adding measurements together. You got to figure out what happened. The angle 2 went away. Well, how do you just get rid of plus angle 2? Well, you would subtract it. So angle 2 went away with subtraction. Don't call that substitution. Substitution means you remove it and replace it. We didn't replace it. How about angles 4 and 5? How do I know? It says the figure at the right. How do I know those are congruent? Those are vertical angles. So you can write definition of vertical angles. Vertical. Or I will mostly just write VA. I don't got time for that. All right, if I told you 2 angles are supplementary, what would you know about them? Well, you would know they would add up to 180. A lot of our reasons will literally be just the definition of and then a word. That is just the definition of supplementary angles. Or you could just write supplementary, which is what I'll probably do more often. Angle A is a right angle. What do we know about right angles? We know that the measure of angle A would be 90 degrees. How did we know that? Because we were told it's a right angle. That is definition of right angle. All right, I'm done writing definition. I'm never doing that again. But you can just write right angle. Okay. This situation will happen often. You need to recognize it. This is a basic version of it, but there will be some pretty convoluted, interesting, complex situations with this. But if 2 things, in this case angle 8 and 9, equal the same thing, in this case 90, then those 2 things, angle 8 and angle 9, are equal to each other. That's important. Remember it. That's substitution. If I told you angle 1 and 2 are complementary, what would you know? You would know that angle 1 plus angle 2, oh, what am I doing? Plus angle 2 equals 90 degrees. That's what complementary angles do. That is the definition of complementary angles. So see, I told you I'm not writing definition of anymore. P goes to Q, Q goes to R, therefore P goes to R. And that is technically transitive, or we're going to call it substitution. I'm so sorry. AD is an angle bisector in this figure. We go over here. AD is an angle bisector. What do we know? We would know that angle 1 and 2 are congruent to each other. So angle 1 is congruent to angle 2. If you accidentally said equals, that's okay. I'm not going to take off. And that's definition of angle bisector. This person actually wrote out the definition. You can do that, but not necessary. You could just say definition of angle bisector, and I would be okay. I want to take a quick second to explain numbers 11 and 12. They look a lot alike, but they are different. The definition of midpoint. So what does midpoint mean? It means if a point is a midpoint, what does it do? What do midpoints do? Man, it really just won't write. Is a midpoint, then it cuts the segment into 2 congruent congruent parts, or into 2 congruent segments. Okay, segments. Okay, so that's the definition of midpoint. It is the midpoint that creates 2 congruent segments. So let's look at these. If I tell you it's a midpoint, look at number 12. If I said, look at number 12. If I said, hey guys, B is the midpoint, what would you know? you would know that AB and BC are congruent. That is just definition of midpoint. I'm going to call it MP. Okay, what about the other one? Here I told you that AB is congruent to BC. I said AB is congruent to BC. That leads you to believe B is a midpoint. That is technically the converse of that definition. All the converse does in math is it flips the cause and the effect. This will matter more. You don't have to know this today. We're going to explain and talk about it when you need it, and you won't need it for a little bit. So if you just put midpoint right now, I would be okay. Definition of midpoint. But on this one, two congruent segments created a midpoint. That's the converse. That's the effect. That's flipping the cause and the effect. Usually a midpoint creates congruent segments. That's what happened here. A midpoint created congruent segments. That's the normal definition. So that's a little sidebar. We'll get into that more later, but we got to move on for right now. All right, here's the main event of the whole thing. It is these geometry proofs. These are as gentle as I can get while still getting some of the main ideas I need across. Triangle JKL is equiangular. That's a given statement. I gave you a picture and I asked you to prove 4 is congruent to 1. Okay, let's think about what we can do here. First, we write the given. Triangle JKL is, oh man, this is a long word, equiangular. Oh, that's exhausting. And that is given. Okay. You have the same job every time you do a proof. Listen, 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 listen. Are you listening? Pause right here. Stop right here. Everyone stop here and listen. If you are watching this video, listen. You have to explain the given statement. You have to explain useful parts of the picture independently. Then you can connect them. It'll make a lot more sense over here what I'm talking about. Okay, number 2, explain what this means. We know that angle 1, angle 2, and angle 3 are congruent. That is the definition of the, oh gosh, equiangular. Okay. That's what equiangular means. Equal angles, congruent angles. All 3 of these are the same size. That is from the given statement. I did not need the picture to know that the 3 angles were congruent. Okay. Then we look at the picture. Now we are looking for useful information. It's okay if you put in something that's not useful, but don't put in something that's wrong. So like if you said angle 1, 2, and 3, if you said measure of 1 plus measure of 2 plus measure of 3 equals 180, that's correct, but not useful. We're trying to connect 4 to 1. So we know that 3 and 1 are congruent. We just said that. How about 4 and 3? Are they congruent? Yes, the picture lets us know 4 is congruent to 3. Angle 4 is congruent to angle 3, and that is vertical angles. Now, look at this. We have 4 congruent to 3. We have 3 congruent to 1. Does that mean 4 is congruent to 1? It sure does. Angle 4 is congruent to angle 1. Bonus points. Do you know how big these angles are? Think. We're going to call that substitution. If all these angles are equal, they're all 60 degrees. So that means angle 4 is also 60 degrees. Nice work. All right, 14. We're moving on. We're going quick. You must explain the given statement. You must explain the picture, and then you can connect the ideas. If you do not explain them independently, your proof is wrong. First, we write the given. Okay, I'm done writing givens. I'm going to do this from now on. This is like me. I mean, you're allowed to do this too. I can't. The givens get so long, guys. I don't want to, like, equiangular. No one should have to write that twice. That just feels wrong. All right, so I put that little squiggly, but what does that squiggly mean? It's like having a little scanner. It's like a barcode. I go, I scan it, and what does it say? It says AB equals 9. BC equals 7. That is what that was a terrible robot, but that's what it says. Okay. So what do we know? Well, we don't know anything from the given statement. Now, if I had said like CD equals 9, then I would know A, B, and C, D are equal. But there's nothing like that. There's no vocabulary. There's nothing we can do with the given statement. How about the picture? Oh, it's 16. It's 16. I know it's 16. Calm down. How do you know it's 16? Well, this is 9 and this is 7. Okay, I know. But listen. You can't go straight to say, oh, that's 9. What's 9? AB's 9. So what are you doing? You're replacing AB with 9. BC is 7. Okay, you're replacing BC with 7. But you have to have an equation that stands by itself no matter what these are. So don't tell me AB is 9 and 7. Pretend you don't know that. Look at just this picture. What must be true no matter how big these pieces are? We know that AB plus BC has to equal AC. That's what we know. And if you skip that detail, you are in big trub. AB plus BC equals AC. That is called segment addition postulate. Segment plus segment, part plus part fills in the whole thing. Now, what can 9 do? Replace AB. Now, what can 7 do? Replace BC. If you remove and replace, that is substitution. Okay, and then 9 plus 7 is 16. Is that addition? Is that addition? If you just said that's addition, no. But I did plus 7, mister. I know what you did. But you didn't change the value. And addition implies addition property of equality where we add something to both sides, and we didn't do that. This is simplify. All right, I'm not doing this whole worksheet. There's some pretty decent one here, but the main one I want to look at is number 16. Last one we're going to do, and I'm going to do it real fast. Time is of the essence. Okay, so I rewrote all the given. Is there anything I can do with this? Look hard. Nope. There's no substitutions. There's no vocabulary. Oh, I want you to think for a second. What do you do next? You explain the given statement, nothing to do. Then you explain the given picture. Look at this picture. What do we know? Do we know angle 1 and 2 add up to 90? Yes, mister, yeah. No. No, you don't. There's nothing in this picture that indicates anything is 90 degrees. You got that from over here. You were like, oh, 1 and 2 are inside this angle, and this angle is 90, so 1 and 2 add up to 90. You went so freaking fast that you didn't know what you were saying. You have to write an equation about the picture. Angle 1 plus angle 2, what do they equal? It's 90, No! There's no 90 in this picture. What does it equal? 1 plus 2 equals the entire angle NLM. That's what it equals. And that is angle addition postulate. So segment plus segment, segment addition. Angle plus angle, angle addition postulate. Now, can I take 90 and plug it in for NLM? Can I take angle 3 and plug it in for angle 1? Perfect. And if this is all that's switched, that's okay. That's not symmetric. Symmetric is when you switch it across the equal sign. But really, your answer should match the prove line. So instead of writing another line, once you notice you got it wrong, maybe just erase it and rewrite it the other way. That's technically called the commutative property, not a property we're going to have a high concern about. I don't expect you to say that or do that. Okay. But what did we do? We removed angle 1, we replaced it with angle 3. We removed NLM, we replaced it for 90. That is substitution, and that's the whole proof right there. That is done. But if you don't have this line, if you go straight to this and you say substitution, what did you plug into? What did you substitute? Nothing. That's the answer. You got to have this equation to actually plug into. You have to have an equation that stands alone regardless of numbers. whether it's 90 or 80 or 50, this is true no matter what. This is only true because they told us it's 90. I need a statement that's true no matter what. All right, that's all we have time for right now. There's some good stuff there. Of course, come see me if you need extra help. Love you guys. See you next time.